I chose to use examples from a polygon lesson that we worked on in class together. Student A's work is right here. Student A did extremely well, only making a few mistakes. The first problem she missed was the pentagon. She said there was 2 sets of parallel lines, as well as 5 right angles. One of the reasons I think she thought there was 2 sets of parallel lines is she thought that they were on opposing sides from each other and just assumed that meant they were parallel. As for the right angles, I think she saw that she was able to draw the box like the symbol requires and thought that's what classified it a right angle. She then missed 1 set of parallel lines on the hexagon. I just don't think she realized that there were so many. She did say there were 6 right angles here, which, as you can tell, she started to draw the box and erased them, so I don't know if she changed her mind and just forgot to change her answer. Now we'll take a look at student B's work. He had no trouble until the hexagon, and then he missed 1 set of parallel lines. You can see a lot of his problem-solving strategies from where he tested lines to see if they were parallel, as well as drew right angles to see if he could make a perfect square and realized he couldn't, changing his answer from whatever he was going to write to 0. He drew a lot of his symbols out and made sure that what he was doing was visually there before he wrote any of his answers out. When comparing the student's work, I found this quote from Van de Waal very fitting. Mathematics is more than computing with pencil and a paper and getting answers to routine exercises. In fact, it can easily be argued that computation, such as doing long division, is not mathematics at all. Calculators can do the same thing, and calculators can only calculate. They cannot do mathematics. I found this quote fitting because both these students have different strategies, but both of them did very well on this assignment. As you can see, both students correctly identified all the correct names of the shapes, although there are some spelling errors. You can easily tell that they knew what they were trying to say. You can also see that they all correctly identified the number of sides on each shape. They both missed a set of parallel lines on the hexagon. Student B was more successful because he didn't have the problems with the pentagon problem, but as you can see, this may be due to the fact that he visually drew out everything. So some common errors I noticed were thinking all opposing sides were parallel, as well as thinking all the corners are right angles. Some remediation techniques that I think I could use to help fix this problem is start asking inquiry-based questions, such as, if we draw out this line, do you think they will ever touch? Which student B did, and you can tell that that's how he was able to realize there was not parallel lines. Also, when talking about right angles, do you think that if the corners make a box, if it's still a right angle, or if it has anything more specific? The descriptions of the next step. The teacher is actually planning on further teaching what parallel lines mean and how to tell if a shape has parallel lines, as well as how to spot a right angle and how to tell if it is actually a right angle or just a quarter, as well as how to properly measure to see if a angle is a right angle. And that is the polygons worksheet my students did.